Okay, Chapter 5 final, polynomial addition and subtraction. This is your summative test. The first 4 questions were true and false. There were people who, even though this is now test number 7 for us, still would write down just true or false with no work to support their answer, even though I have said 1,000 times, show something. Make me know that you know something. So for the first question, I couldn't understand how somebody couldn't answer it. This binomial plus this. So these two here, a positive 2x and a negative 2x, what do they make? 0. A negative 1 and a positive 1. Therefore true. They make 0 pairs. Or something like that. I mean, it was up to you what you showed, but even these lines here are at least showing that you're creating 0 pairs, and that's why you're able to justify that it's true. Question 2 says 2x squared y and 2xy squared are like terms. The answer is false. And your answer could be a whole bunch. They share variables, but, and then I would probably use big capital letters to, like I'm shouting, not corresponding, what's the last word I'm going to need here? Corresponding what? Exponents, that's right. Exponents, meaning the x has a 2, but this x has a 1. This y has a 1, this y has a 2. Therefore, in order for them to be like terms, they have to share both the same variables and the corresponding exponents. So false. Question 3, this is a trinomial with a degree of 2. The answer is true. Why? Because of this. That's all the work I had to show. Just circle the 2. That's what determined the degree of the polynomial. And finally, 4 I gave to most people, unless you really screwed it up. I made a mistake with the writing of the question. This would should have been the word 6, but that's not why it was true and false. I wanted you to actually simplify this expression. The number was a mistake, but that was my fault. So if you gather like terms, the negative 5x squared is still first because there's no other x squared. 3x, 5x, positive 5x is next. Negative 7, negative 3 is negative 10. Negative 10 and positive 10 is nothing. So the true answer should have been true. It does become a binomial. But if you said false because of the number 6, I gave you the answer. But if you said false for other reasons, I didn't give you the point. So it goes true, false, true, true. Your next questions, people kind of nailed these. The only thing is I was a little concerned there were 3 people out of 18, which is not terrible. 3 people that still are gathering them not in descending degree of terms. So your 2x squared goes first because there are no other 2x squareds. 4x and negative 6x is negative 2x. And negative 4 and positive 5 is positive 1. A lot of people had that one right. Next question, your x and negative 2x is negative x. There were 5 people that had positive x there. And a positive 5 and a negative 6 make it negative 1. So your answer for 6 is negative x minus 1. This was a gimme. I might as well just have said to you, everybody just write these answers down and I'll give you 4 points. The opposite of 10.5 is negative 10.5. The opposite is negative x squared plus 2x minus 1. That was the easiest 4 points in the entire test. All you had to know was if it's a binomial, each term has to be its opposite. If it's a trinomial, each term needs to be its opposite. There were a couple of people that were really confused by this question because I never asked you fraction questions. I know I had some weird answers. But anyway, those are your answers up to 7. Question 8, circle the like terms in each set. So there's an x, there's an x squared. Those are not like terms. There's a y. Those 2 are like terms because they both share the same variable and a corresponding exponent. And there were 4 people who missed this last one, B. Constants can still be like terms because they just don't contain variables. But those are your like terms for question 8. Negative 2 and 5 are both like terms in terms of just being constants. Next question, gather your like terms, negative 3x squared, positive 1x. There are still some people in this room to this day that use 1 coefficients inexplicably. I don't know why they would still use it after everything I've ever said, why a person would ever write, not just once, 3 times. 3 times write a 1 coefficient. Bizarre. And that's the only thing they lost for their points, which is one coefficient. Question 10, a positive 4 and a negative 4, a negative x and a positive x. Your answer for 10 is just 0. They are, even though they're not in the same order, they are opposite terms. Best seen if you drew it, because a positive 4 would be 4 positives and a negative x. This would be a positive x and a negative 4. And from a pictorial standpoint, you can definitely see how those are going to make 0. 6x, negative 5, almost a gimme. 2x squared and negative x is negative 1x squared, not with the 1. Negative 3x and positive 2x is negative 1x, no 1 needed. And positive 1 and negative 6 is negative 5. Sorry, I should have subtracted those. Well, this is my vision is not great. Positive 3x squared minus 2x plus 6. Ignore that now. 5x squared negative 5x plus 7. Question 13, we have a subtraction and an addition. So the first thing I'm going to do is change this to the opposite right here. So this is going to become this. And now that I'm adding, I'm just going to add all those terms together. There are no other x squared, so 7x squared stays at 7x squared. Negative 2x and positive x is negative 1x, no 1 needed, right, Brent? And then these are 0. Positive 3 is all by itself, sorry, plus 3. So your answer is 7x squared minus x plus 3. Plus 3. And the last question is actually not hard at all. It's actually easier than 13, even though it's worth the same amount of points. Please, please, please gather your terms in terms of degrees. So x squared has to be gathered first. There are no others. Negative 2x, positive x, positive 2x. Your x's are taken care of. Positive 4, positive 2, positive 3. Your answer for 14 is x squared plus 2x plus 3. Question 15 through 19, a lot of people did well. Only 2 people answered it with the actual term, not the letter, which really bothered me. But anyway, 15, 3x is a like term. The answer is g. The only term that's like it, because it has to share the same variable and exponent, is g. A binomial with a degree of 2. What was the answer for this one? 16. Binomial degree of 2. C. Binomial with a degree of 2 and a constant of 0, because there is no constant, so it has to be C. A monomial with no degree. Well, I know that has to be a constant. So your answer is A. Has a coefficient of 2 and an exponent of 1. That is F. And finally, is equal to 4x. No surprise. Even if you didn't know, you looked at all the other answers, you're like, well, none of those equal 4x. Oh, maybe it's this monstrosity here that have to gather like terms. And yeah, that's what it was. So your answer is D. So G, C, A, F, D. Most had 5 out of 5. Some didn't. This one didn't work out well for many people. Remember, if you had your pyramid, and this was 10 and this was 5, or sorry, this was 6, what's this? It's 4. How did you get it? This, take away this, tells you this. Good exercise in logic. Or this, take away this, will tell you this. So negative 2x plus 2, take away 2x minus 2, keep, flip, change. This will be a negative 4x plus 4. Once you had that difficult brick in place, the rest were easy. Negative 4x and positive x is negative 3x. Positive 4 and negative 3 is positive 1. Negative 2x, negative 3x is negative 5x. Positive 2, positive 1 is positive 3. That was worth 3 points. Excuse me. Question 21. Most got this. Model it. So 2x plus 2, x squared minus 2x plus 1. When gathering like terms, gather your highest degree first. Those make 0. So when you actually gather like terms and make 0 pairs algebraically, you end up with an x squared left and a plus 3. Question 22. was done poorly by many. Using algebra tiles, 2x plus 2. From this polynomial, this binomial, you had to subtract these two terms. Now, since I look in that, I have no negative x's. The only way I'm going to get negative x's what's inside that circle total value? Total value. It's still 2x plus 2, right? Me adding these things right here did not change the net value of that circle because those are zeros. But the reason why adding those is important is because now I can take away negative 2x. Done. And I can also take away a positive 1. I don't need to add 0 pairs. There was one person that added an unnecessary 0 pair. You don't need to do this. You don't need to do that because you already have a positive to take away. And when you look at what's left in here, you have 1, 2, 3, 4 x's plus 1. And surprisingly, this one went okay. This was all right. Only 2 people out of 18, 2 did this. I told everybody in this room, when you do a story problem, step 1, always define your variable. Most of you used H. Very few of you actually took the time to tell me what it meant. So define your variable is the first one. If I look at what, since Joe is a boy and Jess is a girl, then Joe is going to be $15 plus. That's not per hour, that's just $15 to get in. Plus he's going to do go-karting, which is 8.50, $8.50 multiplied by the number of hours. Jess, who is a girl, is $10, plus she's going to do the zip line, which is $4 multiplied by the number of hours they were at the park. And then together, they also have this parking thing. They have a together. They're going to have just a $3 parking fee per hour, which is going to be $3 multiplied by the number of hours. So really, the total cost of Joe and Jess going to the park will be Joe plus Jess plus the parking. That's how much they're going to pay. Or binomial plus binomial plus monomial. That's what I wanted to see. And brackets would have been sensational because you really would have shown me you're separating the people in the actual expression. There were a couple of alphas that didn't do that, but that's okay. Once you have this, you can gather your expressions. That works out to be 15.50 times H, or $15.50 per hour they're there. And that makes sense because it's $8.50 for the go-karts, $4 for the zip line, and $3 for the parking. So $15.50 times hour, plus the $25 it costs to get in. That was the expression that represents how much it's going to cost them. Once you know that, they're there for how many hours? 8. Change your H for 8 and solve it using BEDMAS. 80, 120, 124. And once you had that, this, only 3 people wrote this, therefore. Therefore, it'll cost $149 for the day. Most people forgot this, and most people forgot this.